Good evening. How you guys doing?
Good evening, Professor. I'm doing well.
Hello.
Good evening, sir.
Good evening.
Very good. Let's see, there's 13 of you. I think there should be 16. Let me double check. Um, so good evening to everybody. Hope you guys are doing good. I want you guys to open Matlab and open Webassign. So do that right now. Open Matlab and open Webassign. Let me see. So yeah, there should be 16 of you and 13 are present. So I gotta take attendance real quick. So give me 1 minute, please. Okay. Let me get rid of this. Sorry, this will just take a minute. RD, honey. Okay. So I'm just taking attendance. So give me 1 minute, please. Okay, I think I see one person missing, and I got that name. Okay. All right, so I'm on Webassign. Um, I'm hoping you guys followed the instructions that I emailed you a few days ago. But if you go to Blackboard, you can see under announcements my email that I sent you guys. So go to Blackboard, announcements, read, and do. So I typed it in the chat. And that is for those of you who have not set up Webassign and have not set up Matlab. So I have 10 people registered for Webassign, but there's 16 of you. So 6 of you have not signed up for Webassign. And Matlab is a script writing environment that's basically a calculator. It's a sophisticated calculator. It's free for you guys because you're MC students. That's the calculator we're going to be using to do some sophisticated computation. So those are All of the homework is in Webassign, and then the Matlab will be used for computation, and it'll be used in the projects. Let me go over the syllabus very quickly with you. Let me pull that up. Let me see. What's wrong with this thing? What am I? Doesn't it show up? That's weird. This is the syllabus. Let me share that with you. So this is our class, Calculus 3 or Multivariable Calculus. I want to say the first email, my Gmail, is what I prefer. That's the email that I check the most, is the most accessible to me. If you want to email me, please email me at my Gmail. So you can see, let me see. You can see my info. You can see the topics that we're going to cover. And then you can see the grading. This is what I wanted you to look at and remember. This is how the class will be. 40% of your grade is homework. 60% of your grade is projects. There's 5 projects. Every project will use Matlab. So if I discuss Matlab with you, pay careful attention and do it along with me. And you can save your Matlab file scripts as notes. So label them appropriately, put dates, put topics when you save them. The projects, I'm not done writing. I wrote 2 projects. I'm going to write some more in the next few days. But I don't know, are the projects on Blackboard? Maybe not. Maybe not yet. I don't know why it doesn't show. No, I haven't put the projects on Blackboard yet. Okay. So just to repeat myself, 40% of your grade is homework. 60% of your grade is projects. If you purchase Webassign, the electronic textbook is included. And that's where you do all of your homework on Webassign. This is a week by week layout of what's going on in this class. Not a lot of detail, but I just wanted to keep it brief. This week, we're going to cover 9.1, 9.2, and 9.3. So that means today, we're going to cover 9.1 and a little bit of 9.2. Hopefully half of 9.2. So Cesar asked, what about exams? I'm going to try to have no exams. If the math department, who I haven't contacted yet, if they make me give you an exam, then I have to adjust the syllabus. And I'm going to give you one final exam. I'll probably take away the last project and turn it into a final exam if the math department makes me. But so far they haven't. But I'm just keeping that open, just letting you know. Okay, so right now, if I had it my way, no exams. But if the math department forces me, I'm going to make the last project a final exam. And I think it has to be 25% of the grade, but hopefully we don't have to do that. Are there any questions? So let me scroll up a little bit just so you can see this again.
Professor,
Yes,
I have a question about WebAssign.
go ahead.
So, in some of my classes, the WebAssign, we would be allowed multiple attempts on the problems, but in other classes, we would only be allowed like 1 or 2 attempts before it was completely marked wrong.
You get 5 attempts.
5 attempts, okay.
I'm going to go to WebAssign. By the end of class today, everybody should be signed up on WebAssign. Okay. Now I know one person's missing today, but I really want you guys to go to WebAssign and get registered. If you don't know how to, go to Blackboard, go to our class, Calc 3, go to Materials, and then you'll see instructions for how to set up WebAssign. I'm going to show you WebAssign real quick. This is. So I believe when you open WebAssign, it should look like this. I clicked on the student view. So this is what you should see. There's 5 homework assignments, 1 for each chapter. So this semester, we're covering chapters 9 through 13. So can you guys tell me when is the first homework due?
September 17th.
Yeah. So homeworks, they're always due Friday at 8 p.m. Okay. And the first homework, if you open it up, chapter 9. Let's see, it opens up and you can see the problems here. Chapter 9 has 21 problems. Oh, it went backwards. Sorry. There, that's chapter 9 homework. There's usually 3 problems per section. So it's best if you do 3 problems after every class. Do 3 or 4 problems after every class. That way you'll keep up with the homework and you'll always finish on time. So that's question 1, question 2. Any questions on homework? If you have to, go ahead. No questions?
No, sorry, go ahead.
If you have to put the homework dates in your calendar, if you have a calendar app or a calendar at home, write it down so you don't forget, because the homeworks will not be extended. Okay? The homeworks are set. They're not going to be extended. So please get them done on time. So that's about it. 40% of your grade is WebAssign homework, and 60% is the 5 projects. I'm going to write some more projects, and then I'll put them on Blackboard, and so you guys can get a chance to look at them and prepare for them. Every project will use Matlab, so keep that in mind. But basically, I like to use 2 tools. I like to use Matlab, which you have to set up on your desktop, your computer or laptop. There's instructions for that on Blackboard. And I like to use Desmos. So if we're going to graph something in 2 dimensions, I use Desmos. If we're going to graph something in 3 dimensions, I use Matlab. So, but Desmos is just a website. It's not, you don't have to download anything or install. But let me see. So right now I got 12 students. I got 13 students signed up on WebAssign. Very good. There's 3 of you missing. Make sure you get that done. But I would like to continue with
Sir,
today's lesson.
when I enter the code for WebAssign, like it just says processing and stuck, and then when I sign in with my WebAssign, it says you're not listed in any courses.
It says processing your stuff.
No, like I found the class and then I clicked it and it's just frozen. Nothing's happening. I've tried going back and reloading it and stuff.
Okay, that's fine. Let it sit. Give it a few minutes.
All right.
We'll come back to it later.
All right.
Don't worry about that. But right now, let's take some notes. So I would like you to do this every class. Take your notebook out. Get your notebook. Get a pen. Open Matlab and open Desmos. Just have those open at all times. Notebook, pen, Matlab, Desmos at the beginning of every class. That way we're ready to go. Let's see. So today we're going to do 9.1, which is 3D coordinates. And I think we're going to work on problems. What problems did I want to work on? 4, 12, and 19. And then we're going to get into 9.2, which is vectors. And for 9.2, I'd like to work on problems 18, 20, 22. Maybe I shouldn't have typed this yet. Okay, that's fine. So this is what you're used to. You're used to 2 dimensions. Which means 2 variables. I don't want to put a hyphen. You guys are used to 2 dimensions, 2 variables. That's what you did calculus in before. X-axis, Y-axis. 2 variables, X and Y, 2 dimensions, left, right, up, down. Okay? This is a 1-dimensional real number line. And this is a 1-dimensional real number line. Big R are the real numbers. So you got a number line going like this, and you got a number line going like this. If you cross the real numbers, because I just crossed them, right? R1 cross with R1, and you get R2. 2-dimensional real numbers. In Calculus 3, we're going to be doing math in 2-dimensional real numbers and 3-dimensional real numbers, and maybe even 4-dimensional real numbers. The point of multivariable calculus is to be able to do calculus in many dimensions, n dimensions if we have to. So now we're going to discuss 3 dimensions or 3 variables. 3 variables. So you got your x-axis, you got your y-axis, Now, X and Y exist on the computer screen. 2 dimensions, left, right, up, down. Now, the third dimension comes out of the computer screen. It pokes outwards. And that's the Z-axis. So if you can imagine, the Z-axis is poking out of the computer screen. So I can go left, right, that's X. I can go up and down, that's Y. Now I can go in and out, that's Z. You got to be able to think in 3 dimensions. And of course, 3-dimensional space is called R3. So R2 is the real plane. R1 is the real number line. R2 is the real plane. R3 is 3-dimensional real space. I built this thing. If drawing 3 dimensions is difficult, you can buy some wooden sticks and some glue. Where's my glue? If this helps you, you can do this. You get 3 wooden sticks. Actually, I got 1 wooden stick and I cut it into 3 pieces and then I glued them together. Wood glue and a piece of wooden stick. I got this at Michael's. It was about maybe like $6. But I have a better one here. Maybe you can see. X-axis, Y-axis, Z-axis. Or I guess if you want to compare to what I drew on the computer screen, X-axis, Y-axis, Z-axis. And then I glued some graph paper so that you're dealing with space. I'm missing one down here, but if I put it there, I can't hold it. But if you want to, you can always buy some wood and make this yourself. That way, when you're doing homework, you can be like, okay, well, I gotta go this way, and then I gotta go this way, and then I gotta go up. I hope that makes sense. Does anybody have any questions so far? I think you guys are pretty smart. I think you can handle 3-dimensional spaces. It's going to get, as the math gets more sophisticated, it's going to be a little bit harder to visualize. But you should be okay. By the way, I'm recording this lecture. If you want to go back and watch it, you go to Blackboard, Calculus 3, you click on Online Classroom the same way you got here, and then there's a 3-bar menu. You click that and there's recordings. You can see the recordings based on the date. So you can always go back and watch this. But guys, if you have questions, let me know. Interrupt me if you have to. But if not, let's continue with the notes. I want to give you some intuition for graphing in 2 and 3 dimensions. Let's see. I'm going to erase this. Hold on one second. Okay. Some more notes. Follow me carefully. This will be let's do things in 2 dimensions. And then let's do things in 3 dimensions. Let's do 2 dimensions. And then we'll do 3 dimensions here. I'm going to make a few graphs. I'm probably going to make even more after these that I do over here. Okay, so this is 2 dimensions. So we have X and Y. X and Y. Oh, what's wrong with me? But now we got X, Y, and Z. X, Y, Z. Remember, Z sticks out of the computer screen. X, Y, Z. X, Y, Z. Let's start simple. Let's start simple. The point 2, 3. Okay? The X coordinate is 2. The Y coordinate is 3. This is the point 2, 3. But that's the point 2, 3 in 2 dimensions. What if I said plot 2, 3 in 3 dimensions? Well, I gave you the X coordinate, I gave you the Y coordinate, I didn't give you the Z coordinate. So if I'm sorry?
Sorry, it would be a line.
It would be what?
A line?
A line, yeah. So here's the thing. It has to be in 3 dimensions. So it's going to be 2, 3. Now I didn't specify Z. So that means the point 2, 3 exists for all Z. If I gave you a specific Z, then there's no problem. You go 2, you go 3, and then you go, I don't know, 4. But I didn't give you a Z. So that means that that point holds true for all of Z. So here's 2, 3. You go 2, you go up 3. There's a point here. But that point exists for all of Z. So that point gets spread out into a line. And that line is parallel to the Z axis. Like that. So that point is at 2, 3 for X and Y, but then it goes all the way in and all the way out in the Z direction. Please let me know if that's confusing. So here I can go, if I'm here, I can go X is 2, Y is 3, and then it goes all the way in and all the way out through here in the Z direction. So 2, 3, 2, 3 is here, and it goes in and out, parallel to Z. If you have questions, let me know. Let's try this one. Y equals 2. Y equals 2. Now we introduced a variable, y. So this going to be a line, right? The line y equals 2, you go up 2. The y-intercept is 2. The slope is 0. Y equals 2. It's just a straight line, a flat line. So y equals 2. Y equals mx plus b. B is 2. M is 0. So it's a straight line. Y-intercept 2. Slope 0 is flat. Keep in mind, y equals 2 has no mention of x. So y equals 2 for all of x. Okay, what if I do the same thing here? Y equals 2. But in 3 dimensions. Well, we can go up 2. Y equals 2 here. Y equals 2 for all of x. So it's still a flat line. There's still a flat line that goes like that. But remember, that flat line has to hold true for all of z. There's no mention of z. So that line gets spread in the z direction. So it gets spread parallel to the z-axis in both directions. Let me get rid of it. Hold on, let me get rid of this. I think there's a thunderstorm in Montgomery County or across a lot of the US. So if your internet goes out, that's okay. Don't worry. I'll keep going and you can just rewatch this. But this flat line, it gets extended all the way. Let me. And then I can do this. Hold on. So I'm trying to draw a plane, is what I'm trying to draw. I don't know what's wrong with me. So that line gets extended for all of z. So it goes in the positive z direction infinitely many times. And it goes in the negative z direction infinitely many times. And this continues forever. So what you have is a plane. This plane goes on forever and ever. I hope you know what I mean when I say plane. A plane is a flat piece of paper. You got three-dimensional X, Y, Z space. But if you just look at this flat piece of paper, that's a plane. Okay, a plane is just two-dimensional. So that plane is two-dimensional, and it's situated at y equals 2. So it's the bottom plane, but you raise it up 2 units. So that's what it looks like. Any questions about that one? Let's do another one. What do you think this would look like? Y equals x squared. What is the shape of x squared? Y equals x squared.
It's a parabola.
A parabola.
It's a parabola. Yeah. Very good. Parabola at the origin goes like this. And it goes like this, right? Y equals x squared. Okay. You want to do that. That's two-dimensional y equals x squared. If you repeat that in 3 dimensions, you got the same thing. In the xy plane, it's a parabola. But remember, that parabola gets extended, it gets extruded in the z direction because we didn't mention z, so it has to be true for all of z if you don't specify. So that means there's a parabola here. There's a parabola here, all in the z direction. So what you get is this thing. It's supposed to be parallel to the z-axis, whatever. But you get this shape. You get this kind of, it's like a half pipe. You guys like skateboarding? It's a half pipe. It's a parabola, but it's a long parabola. Like you take a pipe and you cut it in half the long way. And that's what you get. And this thing goes on forever in this direction. It goes on forever in this direction. But it also goes forever in this direction. Remember, the parabola keeps going up. Same here. Are there any questions about this 3D long parabola? Any questions? No questions? Take 30 seconds, copy this down. We're going to do some more of these on the next page. So take 30 seconds to copy this down, then I'm going to erase it and we're going to continue. I'm trying to give you intuition. See if you can see things in 3 dimensions. All right, let's continue with some of these drawings. Let me do this. All right, this is 2 dimensions. This is 3 dimensions. Here we go. This is okay. Let me do this real quick. So this next one, what if I do this? What is that? Who remembers this?
That a circle?
That's a circle. Very good. And in this class, you're going to have to remember circles and ellipses, parabolas, cubics. You have to be able to recall them quickly. So when you see something like that, you say, oh, I remember that's a circle. And it's centered about the origin. What's the radius of this circle? Do you guys remember?
1.
The radius is 1. And the center is here. So you go to side 1, up 1, and you have a circle. I'm going to leave it like that. I'm going to move this. I'm going to leave it like that. There, you have a circle. The center is at the origin. The radius is 1. What if I give you this? What if I do
That a
that?
sphere?
That is a sphere. Correct. Now you're saying when you do x squared plus y squared equals 1 squared, that's the Pythagorean theorem. You're saying the distance from the origin for any of those points has to be 1. So when you do x squared plus y squared plus z squared equals 1 squared, that's still Pythagorean theorem. You're saying the distance from any of that point to the origin is 1. So any point in that space that has distance 1 from the origin. So let's see. Let's say that's that, and you got, and then let's say, you got a sphere. And the red is the back of the sphere. Does that make sense? So this point right here, this precise point right here, the x coordinate, the radius has to be 1. So from the center, which is the origin, to the edge is distance 1. So x is 1. But y, it doesn't go up and down. So y is 0. And it doesn't go in and out, so z is 0. That's an ugly ones and zeros. But I hope that makes sense. So that precise point is located at 1, 0, 0.
What if the coordinates were 0, 1, 0? Would that work for the same sphere?
0 means x is 0. 1 means y is 1, and I'll do it in orange. And then 0 means z is 0. So you just describe this point. 0, 1, 0. The orange point is 0, 1, 0. What is wrong with my handwriting? What's so ugly? Hold on. Does that make sense? Whoever asked that question.
Yeah, it makes sense.
Okay, so what would this point, give me the coordinates of the red point. Somebody.
0, 0, 1.
Yeah. It's on the z-axis. It doesn't move in the x direction, doesn't move in the y direction, so 0 for x, 0 for y, but it's radius 1 for z. Very good. Any questions about circles and spheres? So when you get to higher level math, this circle is called S1. And in higher level math, a sphere is called S2. S stands for sphere. A circle is a one-dimensional sphere. A sphere is a two-dimensional sphere. S3 is a three-dimensional sphere. I can't draw that. I don't even know what that looks like. But that's what you use when you get to higher level math and you talk about topology and stuff. Okay, let's try this one. What would this look like? Give yourself, let me see. Think about that. I want you to do it in 2 dimensions. And I want you to do it in 3 dimensions. Think about it. Give yourself a minute. Think about how you would graph that in 2 dimensions, and then what it would look like in 3 dimensions. I'll give you a minute. Hanin, that is correct. Very good, Hanin. So I hope you recognize if you're going to graph something in 2 dimensions, you always want to put it y equals something. So y equals x plus 2, correct? Y equals x plus 2 is a diagonal line. The y-intercept is 2. You go up 2. There's a point there, and it's a diagonal line with slope 1. So maybe something like this. Come on, man. So that's y equals x plus 2. So what if we did the same thing in 3 dimensions? Y equals x plus 2. You graph the same thing. It's a diagonal line with y-intercept of 2. It looks like that. But there's no mention of z. But we want to see it in 3 dimensions. So this line gets repeated over and over, but in the z direction. And what you end up with is a plane. That plane should be not perpendicular. These lines continue in the z direction. It should be parallel to the z-axis. I didn't do a good job of demonstrating that. It's going to look something like that. So yeah, you got a plane. A diagonal plane, okay? The last plane we did was at height y equals 2, and it was flat, parallel to the xz axis. This one is kind of diagonal, if you can imagine what I'm saying. But it goes like that, and it goes forever, right? Forever in that direction, forever in this direction. Any questions about this one? I know this stuff can be confusing, but I think you guys will be all right. Let me see. Try this one on your own. Nah, let me see. I'm thinking. Try, give me a second, I'm sorry. That's too difficult. Yeah, okay, try this one. Y equals x cubed. And you're going to repeat it over here, y equals x cubed. So take 30 seconds. See if you can do that one. Y equals x cubed. Let me do this one. Y equals x cubed. That's a cubic. Remember cubic? Curvy. It has a saddle point. So cubic looks like this. Remember? Y equals x cubed. It goes through the origin. So same thing. In the xy axis, it's a cubic. Let me see if I can, like that. You got your cubic curve. Goes through the origin. But there's no mention of z. So that means for all along the z-axis, you got these cubics. You got them everywhere. And you got an entire sheet of it. So this thing goes like this. And it goes like this. I may have made it too small, but I hope you get the idea. You get this sheet. You get this big long, I'll repeat the sheet over here. You get a sheet. Like this. But the sheet is not a flat piece of paper. It's a curved piece of paper. For example, this is a plane. This is a plane. I can't get it to go flat. This damn thing. A flat piece of paper is a plane. You don't have a plane. You have this. You have a cubic. It's curved, but it's long in the z direction. This is a flat plane. If I can get it to go flat, and then you make it like an S, but it still has length to it. You know what I mean? That's what I'm saying. Any questions? Any questions so far, guys? No questions. Okay, I want to discuss with you the right-hand rule. Okay? Let me erase this screen. Let's briefly discuss the right-hand rule. It's just a orientation convention. That's all it is. It's nothing special. But check this out. You got, I said you had this. Remember I said you got X, Y, and Z. These three branches are only the positive sides. So, right hand rule. Remember that there's still negative components to this. And the negative is in red. Negative y keeps going in this direction. Negative x keeps going in this direction. Negative z keeps going into the computer screen. So there's a special orientation, the right hand rule. You take your right hand, make it look like this. Your four fingers go positive x direction. You curl them into positive y direction. So positive x, positive y. Your thumb points in positive z direction. So if I'm looking at the computer screen, what I drew x, positive x, curl positive y. So that means positive z points out towards me. Positive x, curl to positive y. Your thumb sticks out this way, positive z goes that way. Does that make sense?
Yes.
Okay. Excellent. Practice. Use your right hand. Sometimes the axes, the x, y, z, they're going to be upside down, so you might have to go positive x, positive y. So positive z goes this way. Just always use your right hand. X, curl to y, z it'll tell you what z is. And that's all the positive directions. Okay, so that's the right hand rule. Let me give you distance in 3 dimensions. We're going to do distance in 3 dimensions, and we're going to do midpoint. Midpoint in 3 dimensions. Distance between what? 2 points. You got a point here. You got a point here. You want to know the distance? Let's see. This point is x1, y1, z1. Point 2 is x2, y2, z2. And then d is distance, right? The distance formula is the same in 3 dimensions as it is in 2 dimensions. You still use Pythagorean theorem. The difference of the x coordinates squared plus difference in the y coordinates, what's wrong with me? Squared plus difference in the z coordinates squared. That's the distance formula. Take a second, copy that down. I'm going to give you the midpoint formula in a second. Let me see. I know the midpoint formula. I'm just double checking. I don't want to say anything wrong. Let me see. Okay, whatever. The midpoint. All right. So you got 2 points. Let's do that in red. You got the distance, but you're not interested in the distance. You want the midpoint. You got P1 and you got P2. The midpoint is a point, so it's going to have 3 coordinates. You take the x's, you add them, divided by 2. The y coordinate is going to be you take the average of the y's. The z coordinate is you take the average of the z's. Any questions about midpoint? M is midpoint. No questions? Okay. I would like to do some problems out of 9.1. I'd like to do problem 4. Oh, let me see. Actually, no. One more page of notes and then we're going to practice. Any questions? Can I erase this page? Anybody still taking notes? Okay. Let me erase the page. Let me see. You guys, when I teach, I usually teach very slowly. Just a heads up. So this is how I do it. Let's talk about a circle, and let's talk about a sphere. The formula of a circle is x minus h squared plus y minus k squared equals r squared. The radius is r. The center is located at h comma k. Okay, a sphere. What's the formula of a sphere? X minus h squared. What's wrong with this thing? Come on. Plus y minus k squared plus z minus, let's say, p squared equals r squared. So you can see that the center is located at h comma k comma p, and the radius is still r. And the center of this sphere is h comma k comma p. Any questions about circles and spheres? Please let me know. Circles and spheres. If I change the equal sign, if I do less than or equal, then you have a disk. If I change this equal sign to less than or equal, then I have a ball. So the sphere is the boundary of a ball. You're playing basketball, you're touching the sphere, but there's, the interior of the ball has air. Let's say bowling ball. If you're holding a bowling ball like this, you're touching the boundary, the sphere, but the bowling ball is not hollow. It has stuff inside that makes it a ball. And a circle is the boundary of a disc. Imagine like a plate or like a CD, but with no hole. This idea of boundary is going to be very important because Calculus 3 culminates with a chapter called Vector Calculus. And vector calculus has a lot of it is under this umbrella of the generalized Stokes' theorem. So you're learning Calculus 3 so that you can eventually be comfortable with generalized Stokes' theorem. This whole course pretty much culminates to that. Generalized Stokes' theorem comes in 4 varieties. But generalized Stokes' theorem, you have to be comfortable with this idea of boundaries and derivatives and integrals. But you're going to be looking at the boundaries of surfaces. So that's why I introduced this idea of disk and ball, circle and sphere. Okay, enough of that. Let's practice. I want you guys to try number 4 in the textbook. What the heck? Let me see if I can make this bigger. This one. Here we go. I want you to do 4. I give you 5 minutes, okay? So at 6:22, think about what they're saying. The XY plane, the YZ plane, the XZ plane. Projection means shadow. Okay, if you have a point in 3D space, over here, it casts a shadow on this plane. This is the XY plane. This is the YZ plane. And then down here is the XZ plane. So if you got a point in space and it casts a shadow on the coordinates, it's in space, but I want it here. It casts a shadow. That's projection. So think about number 4. Try it. I'll be right back. Okay, let's try this one, number 4. Let me write this down. So right now we're doing number 4 from the textbook. The x, let me see, x, y, y, z, x, y, y, z, and the x, z planes. Plane. Plane. Remember, plane is a flat piece of paper. I don't know what's wrong with this pen. It messes up sometimes. They want the coordinates of the projected point. So x, y, there is no mention of z. So that means z is 0. Y, z, there's no mention of x. So x is 0. And then the x, z plane, there's no mention of y. So y is 0. This is, when I say plane is a flat sheet of paper, I mean that even like this flat sheet of paper. If this is x and this is y, this is the xy plane right here. So the x coordinate, and it was for the point, I believe the point was 2, 3, 5. And when they say projection, they mean the shadow. So 2, 3, 5 is somewhere in space. But if you project it to the plane, where does it go? If you project it to the plane beneath, where does it go? If you projected the plane back here, where does it fit? Where does it go? So the coordinates stay the same. So this is 2, this is 3, this is 3, this is 5, this is 2, this is 5. That's it. That's all you had to do. Like this. Let me see if I can draw you a picture when I say projection. Two, 3, 5. 2, 3. You go to the right 2, up 3, and then this way 5. So maybe like it would be here, but then you move it. Be like somewhere here. I don't know. I'm gonna say right here. I'm just making that up. Okay. But if you project it onto this is x, this is y, z. If you project it onto the xz plane, you're pretty much removing the y. So you go down y, and it's here in this xz plane. If you get rid of the y component, and that means it's 2, 0, 5. The xz plane, that flat bottom, if you take the red point, its shadow on the bottom is located at 2, 0, 5. I feel like I'm over explaining, but I just want you to get the point. Wendy. Yeah, Wendy, this is in 3 dimensions. So you still have to keep all 3 coordinates. So let me see. So Wendy, if you write 2, 3, is 2 the x coordinate and 3 the y coordinate? Or is 2 the y coordinate and 3 the z coordinate? So we're still, even though we took the shadow of the point, it went from here to here. This shadow is still in 3 dimensions. It just happens to hit the plane. So yes, you have to keep an x, a y, and a z. Okay, no problem. The next part of the question, if you have a rectangular box with a point at the origin and a point at 2, 3, 5 as opposite vertices, find the length of the diagonal of the box. So let me draw a picture. They say you got a rectangular box. Let me erase this. And we're still working on 4, okay? Here we go. Is that the right size? Hi, Saleh, how you doing? Glad you could join us. Saleh, this lecture is being recorded, so you can go and rewatch it at a later time to see what you missed. We could talk after class if you want to talk. That's fine. It's okay. So let's say this is the y-axis, the x-axis, and the z-axis. But you got your rectangular box. My handwriting is terrible. The question said, you got a point at the origin. Come on. So that's the origin. The origin is 0, 0, 0. I didn't get the dimensions of the box visually correct, but if you go in the x direction, remember that x was 2, so this is 2, 0, 0. Y was 3, so this point is 0, 3, 0. The z coordinate was 5, so this point is 0, 0, 5. If you go this way, you're in the xz plane where it's flat. So it's 2, y is 0, z is 5. Because you're not moving up and down in the y direction. if you look at this point, you're on the XY plane, so that means Z is 0, and you got 2 here, and you got 3 here. If you choose this point over here, that's on the YZ plane, where X is 0, Y is 3, Z is 5. Now what they're saying is, you got this point. I'm going to do it in purple. You got this point right here. Big purple point. And that extrudes into all 3 dimensions, so that's 2, 3, 5. They're saying the diagonal. What's the distance of this orange line from origin to purple? What's that distance? Call it D. The distance of the diagonal of that rectangular box. Remember that the formula for distance is the square root of what? You take the difference in the x coordinates. So we're comparing this point, origin, to this point, the opposite corner of the box. So you take the difference of the x coordinates, 2 minus 0. You add that to the difference in the y coordinates, 3 minus 0 squared. Difference in the z coordinates, 5 minus 0. What's 2 squared, you guys? What's 2 squared?
4.
4.
4, very good. What's 3 squared?
9.
9, very good. What's 5 squared?
25.
25, what's wrong with me? 25, very good. What's 4 plus 9 plus 25?
38.
Yeah. 13, 25, 38. So the diagonal of that rectangular box, that length is the square root of 38. What's the square root of 38? 6.1 or something? I'm guessing. Somebody tell me, what's the square root of 38? 6 point something. What is it? I don't have a
It's
calculator.
6.164414.
6.4, blah, blah, blah. Doesn't matter. All right, cool. Thank you. There you go. You found the distance from between those 2 points. And hopefully you can do what I did. You can draw a box. You can figure out what's x-axis, y, and z. And that's it. Problem 4 is done. Any questions about problem 4? Take 30 seconds to copy this down and ask any questions, because we're going to do problem 12 next. But this is, if I had it my way, this is what we would do all day. We would just practice. I don't like to lecture. I like to practice. So every class, we're going to probably do at least 3 practice problems. And I do them slowly. So if you don't like slow, I don't know what to tell you. Get used to it. That's just how it is. But if you have questions, let me know. If not, let's continue to 12. Let me share with you 12. So there's question 12. I want you to do 12. So I'm going to say do 12. I'm going to give you 5 minutes. So that's 6:43 p.m. So everybody work on 12. You got 5 minutes. All right, guys, let's work on number 12. This is 12. This is the center. Is at 1, 2, 3. Passes through the origin, which is 0, 0, 0. It asks for the equation of the sphere. Okay, remember that the sphere is x minus h squared plus y minus k squared plus z minus p squared equals radius squared. Remember that. That should be in your notes. We discussed this earlier. The center is, let's see. The center is h, k, p. So that means h is 1, k is 2, p is 3. So the sphere is x minus 1 squared plus y minus 2 squared plus z minus 3 squared equals radius squared. But we don't know the radius. Now, if you have a sphere like this, if you have a sphere and the center of the sphere is here, that's 1, 2, 3. And the sphere touches the origin, so that means the origin might be over here. 0, 0, 0. If you go from here to the center, origin to center, what's that distance? What would that be? This red line. Origin to center.
That would be the radius.
That would be the radius. So the distance of the line is the same as the radius. So if you can find the distance of that line, you'll get the radius. And remember, distance, which is same in this case is going to be the same as the radius, is the square root of these things squared. And what are these things? The differences in coordinates. So the x coordinate, that's 1 minus 0. Y coordinate, 2 minus 0. Z coordinate, 3 minus 0. What is 1 squared? Tell me.
1,
2 squared.
4,
3 squared.
9,
Very good. Was 1 plus 4 plus 9?
14.
14,
14. The radius is the square root of 14. But I'm not interested in the radius. I want to know what is radius squared.
14.
14. So this is 14, and you're done. That is the equation of the sphere. I think that's what they asked for, right? Let me double check. Find the equation of the sphere. Yeah, that's it. Any questions? Anybody struggling? Let me know if you have any questions. Okay, that was 12. The next thing we're going to do is 19. So I'm going to give you 30 seconds to copy this down, and then we're doing 19. After that, we're going to move on to 9.2, vectors. Okay, this is 19. I want you to do 19. I'm going to give you 10 minutes. So that means 7 p.m. Remember, this class goes from 5 p.m. to 7:15 p.m. Mondays and Wednesdays. When I give you these problems to do in class, do them so that you're sharp and you're ready to go for the homework. But everybody work on 19. You got 10 minutes. See what you can do. Even if you don't know, even if you're stuck, try. Draw something, write down a formula, write down the given numbers, just try. See what you All right, guys, it's 7 p.m. Let's do number 19. Let's do 19. Let's see. So even before I do 19, let me say, draw a picture. I have a sphere. Right? And the center of the sphere is here. That's the center. Located at 2, -3, 6. Now, just as an example, they said when it touches the XZ plane. So the XZ plane, this is Y. Let me see. Y, this is X, and then Z. So the XZ plane, I know the Y is -3. It shouldn't, the center shouldn't be there relative to the axes. But that's okay. I'm just trying to give you a visual. What's wrong with this thing? Okay, so the XZ plane is, I'm going to do it in like purple, is this plane, this bottom floor. So the sphere touches the XZ plane here. So that sphere, the very bottom is touching the floor. And that point, if you're on the XZ plane, is going to be 2, 0, 6. XZ plane has no mention of Y. So Y is 0. So right now I'm just giving you a visual. So if we're going to do the XY plane, we're going to do the YZ plane, and we're going to do the XZ plane. We did XZ plane. A point on the sphere is 2, 0, 6. On the YZ plane, there is no, X is not mentioned, so X is 0, so it's 0, -3, 6. On the XY plane, there's no mention of Z, so 2, -3, 0. So these 3 points are points that exist on the sphere. We have the center of the sphere, and if you have the center and you have a point that exists on the sphere, you can get the radius. So take a few seconds to copy this down, and then I'm going to continue the problem. Again, this is problem 19 in the textbook. So you got the center, you got a point on the sphere that hits the plane that you want. Now we got to get our radius for each of these. So each scenario, 1, 2, and 3, is going to have its own equation of a sphere. Are there any questions so far? Is anyone confused?
Wouldn't the radius just be the value of of, like, if you're looking at the XY plane, wouldn't the radius to be the Z value of that point? The point in the center?
So in this case, this orange point, the radius is that distance, right? And it's a projection. So look, these from red to orange, these are the same, and these are the same, right? So the
Yeah.
radius is 3.
Yeah, so on the XZ plane, the radius would be the absolute value of the Y component. On the YZ, it'd be the absolute value of the X component. And on the XY, it'd be the absolute value of the Z component.
Yeah, yeah, absolute value of the difference in each component that's missing. Yeah, that's correct.
But since you're going
So
from the coordinate planes, the difference is from 0 to that value. So it would just be that value.
that's correct. You are right. So because this is a projection from the center to the XZ plane, the X and the Z stay the same. So when you do the difference formula, you're going to have 2 minus 2 squared, that's 0. You're going to have 6 minus 6 squared, that's 0. The only change is you're going to have negative 3 minus 0 squared, and that's 9, and you do the square root of 9, and that's 3. So yes, the only change was in the y coordinate, and that is your radius. So let me erase this, and let me continue with the problem. This is 19. For the x, we had xy. The xy plane, we had the yz plane, we had the xz plane. The xy plane was 2, negative 3, 0. The yz plane was 0, negative 3, 6. And the xz plane is 2, 0, 6. So, and we're comparing to the center. So the center is 2, negative 3, 6. So we're going to have the radiuses for each. So let me draw a little radius for each of them. These, if you're going to compare, these are the same. 2 and 2, same. Negative 3, same. The only difference is 6. 6 minus 0 is 6. The absolute value of that is 6. So the radius here is 6. If you do it for the next one, the only difference is the 0 and the 2, so the radius is 2. Absolute value of 2 minus 0 is 2. For the last one, the difference is in the y coordinate, 0 and negative 3. Negative 3 minus 0 is negative 3. Absolute value of that is 3. So the radius is 3. So if you're going to translate so that we get the formula for each, the center is going to be the same. So it's x minus 2 squared plus plus 3 squared plus z minus 6 squared equals, radius is 6, so this is 36. On the next one is going to be the same stuff, equals 4. On the next one is going to be the same stuff, equals 9. Is anyone confused? But is this general format, right? Because the center of the sphere does not change, but you got 3 different radiuses. When radius is 6, when the radius is 2, when the radius is 3. So let me see. Hanin, you use the original, you use this, Hanin. So Hanin, the minus 2, the plus 3, and the minus 6 is the center of the sphere. And all 3 spheres have the same center, so that doesn't change. What changes is the radius, because the sphere, sometimes it touches this plane. Sometimes it touches this plane. Sometimes it touches the plane back here. So the radius is changing. The radius are 6, 2, and 3. So when you put it in the formula, you square it, 36, 4, and 9. I hope that makes sense. I didn't, this one I hope it makes sense. So what you do is you compare, okay? You compare this point. How far is this point from the center? 6. How far is this point from the center? 2. How far is this point from the center? 3. I bypassed the distance formula because I recognize there's a 2 here, there's a 2 here. There's a 6 here, there's a 6 here. So there's no change. The only change is from here to here. The distance from 0 to -3 is 3. The distance from this 2 to this 0 is 2. The distance from 6 to 0 is 6. So that gives away the radius. I hope that makes sense. Look, it's 7:13 p.m. We're done for today. Real quick, what percentage of your grade is homework?
40%.
40%. What percentage of your grade is projects?
60%.
60.
60%. Where do you go to find the homework?
Webassign.
Webassign.
Webassign. And when is the first homework due?
September 13th.
September 13th. I think it's September 17th.
The 17th.
So write it down. Will any assignments be extended?
No.
No extension. So get it done early if you can. That's it for today. Let me see. I'm on Webassign and 14 people are registered. 2 of you are missing. If you're having problems registering for Webassign, let me know. If you're having problems installing Matlab, let me know. We need to get those set up. And are there any questions? Any questions?
My website is still like not working.
It's still not working. Okay. How do you say your name? Abby?
Yeah, Abe.
Abe, stick
Mhm.
around and I'll talk to you in a minute.
All right.
But if there's no questions, that's it. I'll see you guys Wednesday, 5 p.m. Thank you.
Thank you,
you,
Professor.
Professor.
Have a good night.
All right. Thank you, Professor. Be safe.
Thank you.
Thank you,
Good night,
Professor.
everybody.
Have a nice night.
You too. Thank you. Bye, everybody. No problem.
Goodbye, Professor. Thank you.
See you later.
See you.
Take care. Abe,
Yeah.
so you're registering?
Yeah, it's like I go to Webassign and touch enter key, and then it takes me to the place and I enter the key and it just says dashboard enroll on the tab and it's just frozen.
Dashboard enrolled.
Enroll.
Let me see. Abe. Okay, so it says you're not enrolled. Can you put in the chat the link that you're using to register? Give me the link.
Like the actual link of the page that's frozen.
No. The first link that you click on to register.
Okay. One
Give
sec.
me that link.
I gotta go back.
Okay, Professor. Have a good day.
All right, take care, Sally.
Mm.
There you go. That's the one.
Getenrolled.com. All right, what's the course key? Tell me what you put in.
Right here. I put in Montgomery College and space 8392 space 4373.
Montgomery College, one word, space 8392 space 4373.
Yeah.
Okay, and then you hit enroll.
And hit enroll, and I see your class, math 280, 220.
Yeah.
Camilo Diaz 22204, and I touch
Yeah.
continue, and
Continue. Yeah.
then this freezes.
It's frozen.
Yeah, just it's a blank white page.
Okay. I hit continue. And it took me to the correct website.
Oh, yeah.
No. It's still just a blank white page.
Yeah, just a blank white page.
What are you using? Google? Are you
Yeah,
using Google
Google
Chrome?
Chrome. Yeah.
Are you incognito?
Nope, it's just a normal account.
I
I can try
think.
to Edge or something if you want me to.
What do you say?
I can try it with a different browser like Microsoft Edge or something if you want.
You can try that. You might have to contact support.
Google Chrome support?
No, Webassign.
Oh,
Webassign.
other.
Student support. I'm sorry that I wish I had the solution, but
No,
try it
it's
on
not
Microsoft
it's
Edge.
all good. One second.
Try it on Microsoft Edge, and
Yeah,
in the
I'm doing that.
meantime, I'm gonna look for a phone number
All right.
you can call. I mean, you see that phone number?
1 second. Yeah, I see that.
That's WebAssign customer support. If you have
Okay.
20 minutes, call them and tell them what the problem is. But here, I'll give you the link. You can do a chat. You can do online chat, I think. Let me. So if you click that link, it has the phone number and the online chat at the bottom.
When I tried it on Microsoft Edge, it takes me to the sign-in page where it normally freezes.
It takes you to the sign-in page.
Yeah,
Wait a second.
like when I enter the code, it like loaded and then so.
Sign-in page. And it's been loading the whole time?
I just signed in just now. It asked me for my account. Okay, now it says enter access code. Now, if you have one.
Welcome to
Ready to
Cengage.
buy, here are your options. Yeah, I think this is working this time.
You think it's working on Microsoft Edge?
Yeah, it says pick your purchasing option, single term, single term.
Yeah. Does it have an option for free? A free option?
No, it's $60 and $100.
Okay. Then I guess you gotta go with. It's the
What's
cheaper
the
one.
difference between the two? Is there something included in the $100 that's not with this one?
Does it in the 60? All you only need two things: the homework
Mhm.
and the textbooks. Is that in the $60 one?
No, that's homework only. So this one is homework and ebook for $100.
Okay, so what do you want to do? You want to go without the textbook? You can if you want, but it might be
There's
more
no
difficult.
other way I can get the textbook, is there? Like online or something?
You can buy it online, but it's probably gonna be more than $40.
More than $40. Yeah, I'll just buy the $100 one.
Okay, yeah, that's probably the best thing for you.
Yeah.
So let me see if you're set up on my thing.
I probably have to buy it first, don't I? Before I get registered.
Oh yeah, you gotta buy it first.
Alright, wait, let me. I don't have any money right now. I'll ask my mom for so much she gets here, and I'll buy it.
Yeah, I'm sorry that people have to spend money, but
No, that's all good. It's not-
so Abe, you think you'll be able to continue and set it up?
Yeah, I'll do it. I'll do it when my mom gets here to finish it.
Excellent.
And,
Any other questions, Abe?
Matlab as well. I've never used Matlab, so when I tried it, it was a little bit weird. But like, I created an account. I'll finish that.
Yeah, if you set up Matlab,
Mm.
and if you can make it look like this, let me see. If you can just get this to open, and if you can see this, you're good.
Okay.
I'll tell you what to do after that. Just make sure you download it and you can open it and it looks like this.
Okay. Yeah, I have the overview, so I'll do that as well.
Yeah, you should be good. And we're not gonna touch MATLAB for maybe a little bit next class, but don't worry.
All right. I'll still set it up though.
Yeah, and put some batteries in your smoke detector.
Smoke detect?
Yeah.
What do you mean?
Right? Isn't that your smoke detector going off? The beeps?
Wait.
What does that mean?
I don't hear anything.
Hold on. I was hearing it earlier.
Could it be yours, maybe?
Is it mine? Might be.
I'm not sure.
What
Mine
was
might
that
be
beep? Yeah, that beep
I'm-
right there.
I'm not hearing it.
You're not hearing it?
Mm-mm.
Oh. Let me see. Hold on. Whatever. Don't worry about it. All right,
All
Andre.
right.
I'll see you Wednesday, man.
All right. Have a good evening, sir.
You too. Bye.
Bye.